Okay, so we're going to talk about the linear equations and systems diagnostic. You should have already taken this, so we're just going to kind of review it. So it says, look at the system of equations shown. What is the x-coordinate to the system? So what you guys can do is you can just set them equal and then solve. So each of them is y equals. So you do 3x plus 7 equals 2x plus 8. You want to get your variables on the same side. So x plus 7 equals 8. Opposite of a positive is a negative, so x equals 1. I think this is the easier, faster way. If you weren't sure, you could have taken every single one of these answers, substituted them in for the x, and made sure that they worked. For me, I would have just solved it because this multi-step equation with variables on both sides really didn't take me that long at all. Alright, so for this next one, all I would do would be process of elimination. So it says it wants the solution. The solution is just where it meets, okay? So that's what we're looking at right here. So negative 1 is down here. That's not where they meet. Get rid of that one. 0, 5 is up here. Not where they meet. Get rid of that one. 0, negative 0.5 would be right down there. Not that one, so your only option would be the last one. Negative 0.6, 1, and that's going to be right where they cross, okay? So for problems like this, you can definitely just do process of elimination and get rid of what you know it is not. Okay, so this one is really similar to the first one. It says the equations for two distinct lines are given. What is the x-coordinate and the point of intersection? So again, you could take all of those answers and substitute them for x. For me, that's a lot more work. They're both y equals. That means y equals negative 6x plus 20 and y equals 5x minus 13. We talked about it because that's both where the y's are. You just set them equal. So I'm going to add 6x. So 20 equals 11x minus 13. Get rid of the negative 13 by making it a positive. So now I have 33 equals 11x divided by 11. So x is going to be 3. Okay, so this one is a little different. It does take a little bit longer because it's asking for the y value, not the x value. So for this one, you could substitute it in and you'll get the right answer. I'm going to show you how to do it with solving for the equation just to make sure you understand. So it says each of these are y, so 4x minus 2 equals 3x minus 1. So we're going to solve this, but when we solve it, it's going to give us x, okay? So x minus 2 equals negative 1. Add 2, so x equals 1. Okay, but that is x, not y. To figure out what y is, we're going to take whatever x is and substitute it into one of these for x. So y equals 3. Instead of x, I'm putting a 1 minus 1. Well, 3 times 1 is 3, minus 1 is 2. So our answer over here would be 2. And then you could check that on each of them. So it should work for both of them. So you should be able to do 2 equals 4 times 1 minus 2, because we said y is 2, x is 1, so I subbed that in. Y is 2, x is 1. So 2 should equal, well, 4 times 1 is 4, and 4 minus 2 is 2, so it does work. So you can substitute it in, or you could solve it using the actual process of solving a system of equation. As long as you guys understand that, you'll be able to figure these out. Okay, so this one is just solving a simple equation. This is just 0.2x or 2/10x equals 10. We need to divide both sides by 0.2. So I have 10 divided by 0.2. But remember, you cannot have a decimal on the outside. Decimals are at the end of whole numbers. So if I move this guy one time, I need to move this guy one time and add a 0. So this is just saying what is 100 divided by 2. So you should know that 2 times 5 is 10. Bring down your zeros, so your answer is 50. Okay, same thing if you weren't sure, you could have taken all of these x values and plugged them in if that was the only way you knew how to solve it. Okay, so this next one was a free response. So all you had to do was solve for x. So first step is we need to get x alone, so we need to get rid of 1.5. Opposite of a positive is a negative, so we subtract. So now I have missed my decimal, 0.25x equals, remember to line up your decimals, so 5 minus 5 is 0, 3 minus 1 is 2, okay? So then we have to divide both sides by 0.25. Okay, so again, remember, you have 2.0 divided by 0.25. You cannot have that decimal on the outside. So if I move this twice, I move this twice, add a 0. Well, guys, this is just 200 divided by 25. And if you guys think about it in quarters, I feel like it's much easier. So, like, one thing you guys can do is think of, okay, so 4 quarters is $1 or 100. So if you add 4 more quarters, that's going to be what? 200, right? So if you want to check it, you could take 25 times 8, because that's how many quarters I used. 5 times 8 is 40. 8 times 2 is 16, plus 4 is 16, 17, 18, 19, 20. So your answer is 8. Whenever I see something with 25, I always think of quarters because money is something you guys use every day and it makes more sense. So if you do that, that might be easier. Okay, so I'm going to rewrite this one just bigger just so I have more room to work with it. So this is like the multi-step equations that we've been working on. I have another video that explains how to do these, so if you're not sure, you can do that. So step 1, you could distribute. So this 3 gets multiplied by everything inside. So now I have 6 minus, what's 3 times 8? Hopefully you know that. Okay. Then for me, I would add this to both sides just because then it gets rid of that negative. So 6 equals 27n plus 6. Subtract 6, well 0 equals 27n. And if you know you have 0 and you divide it by anything, your answer is just 0. Again, if you're not sure, you could plug it in and check it. But that's up to you guys. So that means you could plug in whatever these are down here for n's and see if it works. For me, I would rather just do all of this stuff because it's faster for me, because once you understand the process, you're going to be able to understand how to solve all equations. Okay, and then the last one, again, I'm going to write a little bit bigger just so I have some more room. So this one, I know that you guys get freaked out by fractions, so let's just work with this. So we need to subtract 2/3 minus 2/3. The reason I'm writing it over here is because I need to figure out how to have a common denominator. Okay, so all this is gone. I just have this over here. This is my problem. So right here, this denominator is 3. I need to figure out how to make this 1 of 3. So to do that, I can just multiply the whole thing times 3. So 2 times 3 is 6. 1 times 3 is 3. Now I have a common denominator of 3, and I can just subtract. So I have 1/3 equals 6/3 minus 2/3. Well, 6 minus 2. 4/3. Okay, so now I have 1/3 x equals 4/3. This right here is multiplication. I need to divide. But if I actually divided it by the fraction, it wouldn't do anything. So when we divide fractions, we multiply by the reciprocal, meaning we flip it upside down, because that's how it's going to cancel. 1/3 times 1/3 cancels out. 1 times 3 is 3, 1 times 3 is 3, 3 divided by 3 is 1, it's gone. So we need to do the same thing on this side. So I have 4/3 times 3/1. Okay, so you can multiply straight across or you could cross reduce. So if I multiply straight across, I have 4 times 3 is 12. 3 times 1 is 3. 12 divided by 3 is 4. Okay? Or you know that you could just reduce. 3 divided by 3 is 1. And then now I have the same answer. Well, 4/1 is just 4. I just now realized that I left the answer there for you guys. So hopefully you figured that out. But another way is you could take all of these values and substitute them in for x. But even then, you're still going to have to figure out how to add them all. It's just going to take more time. So totally up to you how you want to do it. Process of elimination, solving it, whatever you think is best. We've taught you all this stuff, so this is kind of just a review. So again, if you need help, message me and I can set up a session with you and we can help you out on this.